sometimes we can understand interest rate behavior way easier than what is happening in currencies. So Taylor rule is quite a strong functional relation between variables, and we can use them quite efficiently to model economy. So this is John Taylor. He was working at the US Fed, but at the end of the day, he landed at the US Treasury. I don't know how or why, but doesn't matter. And his work was published in the early 90s, and nowadays we are using it generally everywhere in central banks. Unfortunately, he did not get any Nobel Prizes still yet. Again, I don't know why, because this is a generally used framework to describe most of the monetary policy's reactions, but obviously there are maybe much more important things in economies than stabilizing currencies and setting interest rates. So, in this framework, he was saying that, okay, if we are setting or trying to determine the key policy rate, which is I, here, then we have to consider the following variables. So first of all, we have to consider this unknown variable. So this is the equilibrium real interest rate. At his times, it's supposed to be 2%, because this equilibrium real interest rate should be the long-run stable interest rate where all the other interest rates are fluctuating around. Nowadays, it's 0.5% if you are looking on recent papers. But okay, he needed some anchoring value. Also, we should consider inflation. And also, there is another component when we are considering deviation from the target. So this is the targeted inflation, the 2% here. And this can be the empirical inflation. So in this case, we have a backward-looking model. In his time, it was a backward-looking model. Nowadays, we have inflation expectations when we have forward-looking models. Just the problem is that in this case, we have to model somehow this inflation expectation, so it's less reliable than the backward-looking model. And of course, we have the output gap, so we have the potential output, we have the output itself, and this is what we have. Maybe it's easier to exit because we have many slides here. So when I started last week, let's focus on the Eurozone. So when I started last week's class, I was starting with that, why we have business cycles. And in this case, what you can see here, that this is the empirical data about the output, represented by manufacturing index in the Eurozone. So these are the blue lines. This is the potential output, the long-term trend of the data with orange. And what remains, so if we are taking the difference of these two lines, will be this red dotted thingy, which will define the cyclical component. So obviously, if this is negative, so this is the scale of this red thing. So if we are in negative values, then it means that we are under what the potential growth or potential output. If it's positive, then if we are sitting in an overheated economy, so we should do something with economy. So that was the idea behind the Taylor rule, because in this case, because in this case, we can assume that if we are in an overheated stage, then we should, so this one is positive, then we should increase the interest rate. Also, if we have higher inflation than the target, we should increase the interest rate. And also, if we have high inflation, then we should increase it more. And at the end of the day, this will define the level of the interest rate. So after that, during the whole 90s and 2000s, people were trying to refine the Taylor rule by setting different coefficients, by adding, removing variables, and so on. So last year, I had a wonderful 1 week when I had to process the whole literature about Taylor rules. So there are many. Last, what I can see. No? And yes. So I collected some of them for you because obviously we don't want to go through everything. So if we are just going through the set of list of the different rules, then we can see that the balanced Taylor rule suggested that we should increase the importance of the output. In the United States, and we can see that she was the head of the central bank at that time, Miss Yellen, and also Williams is a really important author in the field of monetary policy, also from the US. So they were saying that, okay, this is more important, not just inflation targeting, that we should focus on unemployment level. But also, Bernanke, who was also the head of the US Fed he started his career when the global financial crisis was hitting the US, so he had a really nice journey or experience during this time period. So Bernanke said that it's much better if we are adding inertia. So past values of the interest rate should be added to the model, because in this case, obviously, interest rates will react slowly. And this process will remember what happened in the past. So usually this inertia is around 0.8, 0.7, 0.6, something like this. And the rest of the data will be the same. But if I'm looking for modern models, then we have always these forward-looking models. So, for example, this was designed for Poland by the IMF in 2026 by linguists, and in this case we can see that they were saying that, okay, this is quarterly data, so they were looking 1 year ahead in case of the inflation. So what are the forecasted inflation for Poland? And then they were just taking this is this equilibrium interest rate, just they had different setting for that. And otherwise we can see that, okay, if we are deviating with these inflationary expectations, then we should already react on this one. The problem is that only the ECB and the US Fed publishes anything about inflation expectations. So the remaining central banks are not doing it, or doing it only 1 year ahead, or then just publishing some kind of a data, but after that you have to convert it to have any growth or decline or something. We can have Reuters polls from experts from the market, but also whenever we were trying to calculate with that data, it was also really hard. So this is nothing like that, I will just go on the internet, download the proper Excel sheet, and after that I can work with this one as it's supposed to be. So when my boss had to collect it, luckily I was not part of the procedure, because she was working for maybe 3 weeks until she was able to collect all this data for all European central banks. So this is terrible. Also, it's quite funny that, for example, when Taylor tried to model what is happening in the euro area, he realized that only future inflation expectations will affect the interest rate, so nothing about the output, and even 2 years ahead or forward interest rate or inflation expectations. What matters here? Also, in proper economies, governments are issuing inflation targeting bonds. So when the bonds yields are paying according to inflation, so let's say that the inflation is 8% and inflation plus 1% is paid, or inflation plus 0.5% is paid. So there are always these inflation-linked government bonds, and if they have stable secondary markets, and also we have many of them, and if we can pair them with proper variable interest government bonds, then we can also see from the difference of the prices of these bonds that what are the inflation expectations. So this is how the US Fed collects the data about inflation expectations on the market, because in this case we can see the difference of two assets which otherwise supposed to be the same in maturity and other conditions, but since this inflation defines the interest payments, then that's why the expectations about this will determine pricing. So, in case of US Fed, we have this data. In case of the Eurozone or otherwise, in other countries, we doesn't have this data. So, unfortunately, in Hungary, households can purchase such government bonds, but since it doesn't have any secondary market, so you can buy it from the treasury, you can sell it back to the treasury, or you can sell it to your bank, but the bank is not able to trade with it. So they can sell it only to other households as clients. So that's why we can't have price data to do similar estimations, which is really sad for me as a researcher. Okay, so after enough raging about insufficient data, we have also foreign exchange rates. In open and small economies, we have this because of import prices, but it's really funny that Ball, which is who is a really important economist, or he was at least at that time at the US Fed, made also a model, and he realized that also this is relevant for the ECB. And it's still really powerful because in my own empirical model, I will have this data when we were modeling it with BOSS. Last year, we also had similar results, so it's still, we should consider interest rates, exchange rates if we are modeling interest rates within the European continent. Why? Because in open economies, we can say that, okay, exchange rates are always the subject of the interest rate differential and some random variable, but this random variable will be determined by the Phillips curve and the ES curves sum. So if you are adding them together, then we can see that it will affect interest rates. So at the end of the day, how can we calculate this? So for key policy rate, usually people are using the overnight interest rate, 1 month or 3 months in interbank market rates, or treasury bill yield. So it depends from paper to paper, and also what can you have as a data, because in some countries data is absolutely missing or completely missing, so you can cook what you can find. Also, inertia can be anywhere between 0.4 and 1. Again, in this case, it's much reliable if you are just putting regression on the empirical data, and after that we have to calibrate everything to have any idea about the inertia level. Inflation, nowadays backward-looking models are not preferred. So everybody is building forward-looking models if we have proper data, and also core inflation is much more preferred than ordinary inflation, because in this case we can get rid of food prices, we can get rid of energy prices. So everything which is coming from exogenous shocks like climate or disasters or different wars in different oil extracting economies. So yeah, so it's more stable. Output gap, it has high conclusion, or it's coherent that people in the US, they are using unemployment data. In the EU, we are using manufacturing indices because they are much more reliable. We could say GDP, just GDP is way too aggregated, and in many cases, whenever even I tried to use it, even at classes just for illustration, it was not significant. It's not changing enough, so it's not flexible enough, the problem with GDP. So manufacturing is a better indicator because it's generated on monthly basis, while GDP is generated only on quarterly basis, so it's lower. Equilibrium interest rate. This is a non-observable long-term maximum stability providing variable, which was assumed to be 2%, but nowadays, if you are checking the different data, we can see that it's 0.5%, 1%. In emerging economies, it can be still considered as 2%, but yeah. Okay, so how can we do this? So what is the procedure if we would like to do this for the euro area to make our own Taylor estimations? So first of all, I collected 3 months euro deposit rates from the euro area, from Refinitiv Econ database. Also, we can download something from the ECB's website, just this is faster. Also, we can have the 1-year inflation expectation data from the ECB, which is really sad because they are advertising it that this is mostly data. If you are downloading that this is quarterly data, just all the other months are missing, and only in the beginning of the quarter we have data in this, so it's not nice. Manufacturing data we are just downloading from Eurostat. In my examples, I was always showing you Hardy-Prescott filtering, but nowadays this Beveridge-Nelson filter is preferred by central bankers because in this case the first 3 quarters of years are not jumping back and forth what is happening in the HP filter. So now this is the fancy approach. Unfortunately, Beveridge-Nelson filtering is not even part of Stata or other mainstream software, so we have to always look for some external functions, libraries to add this to the software. So it's so new that people did not add it yet. And of course, US dollar euro exchange rate for foreign exchange rate because we need something. It could be also net efficient or real efficient exchange rate. Just for some reasons, I did not add that one, so I use this one, even if I have the data for that. Oh, and this poor thing died. Okay, so next step, we need OLS regression. It's quite funny because I had to learn vector auto-regression method to model what is happening in monetary economics. But in this case, the reaction of the the interest rate is so instantaneous that simple regression, simple OLS regression can be completely sufficient. Which is good, but also for me this is sad because I had to spend a lot of time to learn the more advanced and proper method. But still we need a training sample. This is always the bottleneck because we have data from a long time ago. So training data, when we are doing forecast, it should always cover 80%, 90% of the data. But I wanted to show you that how data will react. Can we forecast the inflationary spike of the 2020s? So that's why I collected all the data before COVID, and after that we will see that. What happens if things are progressing forward? So I loaded the things in eViews, and yeah, it's OLS. And also we should not use differences because we are doing forecasting. As a person who teaches econometrics even for PhD students, doing no differences on this data set was hurting my feelings because you should need stationary data for any regression. But this is how people are doing it at central banks. So once I was in a heated argument with people from the National Bank, and still they were saying to me that we should do it this way, even if it's not nice. And also the person who was teaching us for forecasting from the French National Bank, he was also telling me this. So, okay, I can understand it just from methodological point of view. I hate it, but okay. So about my personal feelings, this is what we can see here. So I tested different alternative models, but this was sticking in the best way. So in the empirical data, we can see that these are the coefficients. So this C, this is supposed to be the real equilibrium interest rate, which is minus 0.8. it looks sketchy, but if we are going back to the empirical data, then, oh, I did not include it. So somewhere we had a minus 0.3, so not that sketchy, at least it's significant. Also, we can see this one is here, the inertia. So what is the impact of the past value of or past level of the interest rate on the current interest rate? We can see that is 0.9, so it's good according to literature. And after that, this is the inflation expectation 1 year ahead. Is 0.5, which is really close to the 0.5 what we had in the original Taylor rule, so that was a surprise for me. But in the case of output gap, we have not much, so it's 0.1. Okay, it's significant, but yeah, okay. So it's still we can say that, okay, inflation targeting is relevant for the ECB. And after that, if we are doing any forecast based on this data, so you can see that I made this forward-looking model from 2020 until this year. This is what we had as the empirical data. This is which was provided by the model. So in this case, we have nothing to do, just take this coefficient, multiply the numbers which are related to this one, and then just calculate it. So it's like a weighted average, what we can do here. And it's really funny that, yeah, it says that, okay, interest rates should follow this increase. But what we can see here, that interest rate should be already higher. So it should be positive, or they should be positive. After the initial shock due to COVID, because in this case the output gap was dropping, but once they were recovering from this drop in the summer of 2020, they should go back to 1%. This is missing from the real life. And then already when inflation started to pick up, sorry, inflation expectations started to pick up, then you should gradually increase the interest rate, and this is what was missing. So in 2022, May, where we are already in the middle of the Ukrainian war, already there is the huge energy price spikes, then this is when we can see that ECB realized that maybe we should do something. So they were lagging behind by half a year. As if it's not just my stupid result, this is the particular literature right now. So Boss is also writing paper about it, but also we can see proper journal papers which were published that ECB was lagging behind a lot. This is just one validation. And after that, they started to increase the interest rates, so they started to follow what is happening in real life. And after that, they were able to cut back the inflation expectations. So it was, at least their monetary policy was credible enough to do that, because once they became active, then it reduced inflation expectations, just it was not aggressive enough. And if you are doing proper forecasting with the OLS model, then we can have the same result, which is really funny because in this case I was just teaching the model to focus on, so this model just uses pre-COVID data. But still, they said that, okay, now we should have some kind of an inflationary spike. So in this case, the model had absolutely no idea that there will be a COVID or anything like this. Just it says that, okay, there will be a jump. And this is even significant one because also the confidence intervals are positive with this line. So this one is not significant, what is happening here, but this one it is. And it also follows the actual green line, so it's a nice approach, because also, so without COVID, there was already an expectation about increasing inflation. So if you are checking any press releases from the ECB in 2019, they had an increasing communication about that there will be some kind of an inflation. So this is what we can see, that the interest rate increase was in the books. And also we can run a VAR model for robustness checks, and in this case what we can see here, that inflation expectations were reacting, interest rates were only reacting on inflation expectations. So shocks are coming from inflation expectations, and it has a significant impact on the first quarter, second quarter, third quarter, okay, it's just at 68% of confidence interval, not at 95% confidence interval. So practically the first two quarters, we have a rise. So whenever inflation expectations are increasing, then the central bank should do something within the next 2 quarters of years, if they are not sleeping too well. But it's also fitting that half a year lag behind what's happening. In case of output gap, this is not significant, and also it reinforces itself. If we are checking the relevance, we can see that 1 year inflation expectations have 35% impact on the interest rate after 2 quarters. Yeah, so this is where we should stop today.